All right, welcome to our second video lecture here. So this one again, you need to watch it before the next class, and there's going to be three parts to it. So the first part is this one. We're gonna, on all of them, really be talking about significant figures. And so the first video is going to kind of go into the background of what is a significant figure, where do they come from, and then really the important thing for us in this class is that this idea that you're going to be hearing about, significant figures that is, it's going to have to do with how we write down answers to math problems. How many digits do we put in answers to math problems? So to understand that, we're going to have to talk about significant figures in a number, and then the last video will be significant figures in calculations, looking at significant figures in calculations. All right, so in this one, this has to do with what the heck a significant figure is and sort of where this idea is based on. And this idea is based on how we read a measuring device. So let me go ahead and flip to the next slide, and let's talk about if you were to take a measurement, how exactly do we do that? How many numbers do we give in a measurement? There's a very specific rule for that. Now, that rule says whenever you're reading a measuring device, so it could be like in your lab kit, the thermometer, it could be a ruler, which is also in your lab kit. There could be I don't know, a cylinder that we're using to measure like volume of a liquid. Any measuring device, the way that we read it is we record all measurements to the nearest division, and then we estimate one more. Well, if you want to add on to that, we estimate one more digit. You always estimate one more digit. This is called reading reading an instrument to the correct number of significant figures. This is called reading an instrument to the correct number of significant figures. Significant figures communicate how well a measurement was made. So the basic idea of this is if you have a better measuring device, you're going to have more digits in your answer, more digits in your measurement. If you use kind of a cruddy measuring device, a not a very good measuring device, you're going to have fewer digits in your measurement. So more digits is a measurement that was made more carefully. So with that, let's kind of get into a few examples of that. And again, this will come up maybe a little bit in lecture, but especially in lab, where you actually are going to be taking some measurements. So let's look at a little example of how exactly we take a measurement in science. So the rule of measurement said, determine what the divisions are and estimate one more digit past it. So let's do a little example here. So let's say we wanted to know how long this piece of wood is. So you found some piece of wood laying around and you want to know how long is this thing? How long is this sucker? So you go out and you find a ruler. Maybe you have a ruler sitting in your garage. And when you find it, this is the first ruler you come across. Now, when I look at that ruler, it's not really looking like a very good ruler to me. And the reason why it's not looking like a very good ruler to me is the marks are not very close together. They're kind of spread out. And that means that I can't get a very precise measurement from this ruler. So if I want to know how to read it, I got to take into account that this ruler isn't really giving me a very precise answer. I can't really say for sure really how long this piece of wood is with this ruler because the marks are so spread out. So the first thing I would want to do is I want to figure out what the divisions are, right? So the rule said read to the nearest division. So what do I mean by division? I mean how far apart are the lines. So let's pretend this is in centimeters. 10 centimeters, 20 centimeters, 30 centimeters. The lines are every 10. The divisions are every 10. So what I could say is whatever the divisions are, I want to estimate one number past that. So when I look at this ruler, this piece of wood is between the 60 centimeter line and the 70 centimeter line. So I'm going to estimate somewhere between 60 and 70. Now to me, it looks quite, slightly closer to 60. So I might say, oh, this thing is, I don't know, 64 centimeters long. So whatever the divisions are, the rule says you estimate one more digit past it. So that would mean if the divisions are every 10, I would read to the 1 centimeter. So another way of saying that is I'm going to estimate in between the lines. So when I look at this number, I know for sure it's 60 something. This piece of wood is 60 something centimeters long. But the last digit is sort of a guess. It's an estimate. 60, we're going to go with 4. So it's about 64 centimeters. So whatever the marks are, you estimate one more digit. That last digit is sort of a guess. All right, now let's do another example. Let's say I have the same piece of wood and I want to measure its length again, but when I scrounge around in my garage this time, I find a slightly better ruler. This ruler. Why is it slightly better? The reason why it's slightly better is that it's got marks that are closer to each other. That means that I can make a more careful measurement. And if I have a better instrument with that more careful measurement, I'm going to have more digits in my answer. So what I would always start off with is I'm going to first figure out what the divisions are. 60. This is 61. This is the 62 line. This is the 63 line. This is the 64 line. This is the 65 line. So how far apart are those lines? They're every 1 apart. The divisions are every 1. Every line represents 1 centimeter. So when I read it, this ruler, and I know for sure that this piece of wood is somewhere between 64 and 65. Yeah, it's somewhere between 64 and 65. So for sure, it's 64 something. Now, I'm going to write down the something. I'm going to guess what that something is. 64 for sure. My guess, yeah, it's a little closer to 64 than 65, isn't it? 64 point, I don't know, maybe 3. 64.3. All right, so that would be my reading this time. That would be my reading this time. So the divisions were every 1. Let me write it right here. So I would read one more digit over, read to the 0.1. And in this case, my answer would be 64.3. Now, the whole point of this is not really learning how to read a ruler. You know, we will have to read things correctly in lab. The whole point is I want you to notice when you have a better instrument, you get a better answer. And the way that you tell me you got a better answer is you're going to see more digits in your answer. So this top number here, which was measured with a not a very good ruler, it only has 2 digits in it. The next measurement, the better ruler, had 3 digits in it. So those digits are basically what significant figures are. So we're going to keep track of how many digits we have. More digits is a better measurement. And when we do math, we're going to keep track of those digits as well to show how well we know an answer. Now, the last one I have to say is a little hard to see on this slide because, you know, the measurements are so close, but let me just kind of go through it real quick. So same idea, I have the measurements, I have the ruler. I want to figure out how long this piece of wood is with my fancy ruler. Why is it super fancy? Because look at those marks. Man, they are so close to each other, right? They're practically on top of each other. Now, again, it's really going to be hard to show you this on this screen, but you can tell the marks are closer to each other. That means I would get more digits in my measurement. I can tell you that the marks are actually the divisions, I'll call it. The divisions are actually, I miswrote there. Let me erase that. Okay. The divisions are every 0.1. So every line means 0.1 more. 64, 64.1, 64.2, 64.3, and so on. They're every 0.1. So you would read 2.01. You would have one more digit. So as the marks get closer together, you have more and more digits in your answer. Really hard to read this because it's so small. It would turn out to be something like 64.25. All right. So again, come up with that exact number. I wouldn't worry too much about that. But notice when the marks get closer, we have more numbers in our answer. Those numbers are called significant figures. All right, with that, let's move on to the last slide where there's a little example and give you a chance to practice reading significant figures. All right. All right, so I'm going to give you a chance to try this one, and this is going to be a little question. It should pop up here in a second, and you'll enter the answer. What's the proper way to read this number? Give it a shot. Okay, hopefully you got it right. You had to type it in. And that is the end of this video. All right, so with that, again, we're done with kind of what a significant figure is. It has to do with how well a measurement was made. The next videos are really where we're going to focus on how do we use significant figures in calculations, and specifically, how do we use them to decide how to answer a question, how to round an answer to a question. All right, first video down. If it didn't make any sense, let me know. Got 2 more to go for this lecture, parts B and C. They'll be right up on the internet right after this one. So if you have a problem, let me know. Otherwise, you can move on to the next video.